Well, as a physicist, you can think of the spherical polar coordinate system while flying a kite. This is typically meant for college or research students. Anyway, suppose this is the spool and this person is standing and he is holding a string, this purple string, and I am assuming that this string is straight and this string is originated from this origin O. Okay, origin of coordinates. So this is the origin O. Anyway, so you understand. Now what I need to do is, see, this string, this kite is coordinatized by 3 coordinates in spherical polar coordinates. The length of the string is r. I'm assuming that it's straight, it's not, the string is not slack, so it's not too heavy. And if you drop a perpendicular from this kite to the horizontal plane, and if you join from this origin with this line, what happens? This angle is phi, the azimuthal angle, and this angle is theta. That makes with the z-axis, or this line is what? This line is the theta equals to 0 line. You better use only spherical polar coordinates while using the while coordinatizing the space, because anyway, so that you know. But now what happens? Now if the kite comes down, it should come down. Suppose it comes down like this. It comes down like this. I fly a lot of kites. I love it. Anyway, so suppose it should come down. Sorry, it should come down in the along the longitude. Correct. So along the longitude. Suppose this is the position. I have already drawn this. Suppose this is the new position of the kite. Now what happens? See, if you join this with this, so this is what? This is the change in theta, right? Now similarly, if this kite moves in the horizontal direction, so that means along the latitude, so what exactly happens? So not exactly, I should have taken this line, yeah. So let me manage it, please bear with me. Yeah, I think it is approximately okay. So this thing, now if this is phi, what you need to do is you need to drop another perpendicular from this new position of this kite to the horizon, right? And you need to join from this point to this point. So what is this? This is delta phi. So if it goes this way, along this way, right, so there is a change in the phi in the positive direction. Of course, if it comes this way, in the other side it's a negative direction. Again, if it comes this way, there is a change in theta with the in the positive direction, because as we come down, the theta changes. Now what happens if we allow the kite to go away? So if we allow the kite to go away, what happens? It comes to this position. Sorry, it goes to this position. And what is this section? Only this section. If this is r, this is delta r. So this is delta r, this is delta theta, and this is technically, this length is not delta phi, the change in angle is the delta phi. This is basically, you understand this. What is this? Let's go a little bit of mathematics. Just join this. Let's join this. I think it should be a little above. Okay, that's fine. Now this, see, this is delta phi. Now if you want to get this arc length, you need to know this length. So if this is r, this length is r what? Sine of theta, right? And r, so this is r sine theta delta phi. Clear? This arc length. See, very interesting. If you are holding the string, only, and if you do not allow the kite to go away, what it describes? It describes a sphere. It describes a sphere only, right? Because the length of the string is fixed, so it describes a sphere only. So that's what a sphere is. It's r equals to constant planes. That's the constant equation which we use in classical mechanics, right? Let me give you a section of the sphere. You'll understand. You'll feel better. Okay, so that's very interesting. This is the new position. The sphere looks like a spheroid naturally, because we are, I'm taking it like that anyway. And now this position of this new kite, so this position, right, this position, so we are getting the intersection, and this is the intersection of this new theta line and new phi line, and this portion, this section is the area of the circle. You can easily think of. So this portion is this area of the circle. And if these are elemental, what's this position, this area is, what the area is. So these are orthogonal coordinates, right? This is, what is this length? This angle is delta theta. So this arc length is not r delta theta. This is r delta theta, right? So this is r delta theta, and this is r sine theta delta phi. So this r sine theta delta phi times multiplied by r delta theta. So if these are elementally small, if delta theta and delta phi both tends to d theta and d phi, then this ds, if we take this area as ds is r, 2r you have, so that's r square, then you have the sine theta, then you have this d theta, and you have this d phi, correct? And another thing I tell you, if you go just a little above like this, here, this is a new kite position in delta r, that means it may become a little clumsy, so I don't intend to draw, but anyway, if you insist me, I'll try. What happens is, suppose this position, let's do it in some other color. So take that as red. Okay, suppose this is the new position of the kite, this new position, and this is the new thing. Now see, if here I'm changing r, right, so again this kite will come here, right? You try to understand, this is delta s, we need to get another section. I don't want to make it too clumsy. What happens? We'll get another section. Here the longitude will come, and this kite will go like this. So this is the other section. And if you just make it like this, so this is the section of the higher sphere. Higher sphere means which is at a height dr above. So how do you get dv? How do you get dv then? So dv is basically ds times dr, right? So if you multiply with dr, you get the dv. whole volume. So dV is r square sine theta d theta d phi dr. So what I insist is, think of physics everywhere. Feel it. Feel it. Feel the coordinate systems. Feel. Acha, one thing I want to tell you. Remember this line, this theta equal to 0 line, this is very important. This line, this theta equals to 0 line, or the z-axis in your, or also this line, this line, if you go down, and that means theta equals to pi. This line, if it is go down, it's not coordinatized. It's not coordinatized. That means if you have to go to my webinar. I'm taking a webinar on vector analysis. That's mainly for little high standard students. So not coordinatized because you cannot not coordinatized because sorry because you suppose you take a point P here. Here the distances are right from the origin, but as far as this phi is concerned, phi can be anything. So you don't know anything about phi. Anything you give phi, it will take. Theta equals to 0. That is fine. R is this length. Phi is anything. So because this point, because any point P on the line, on the theta equals to 0 line or theta equals to pi line, is not uniquely labeled by 3 numbers. You will understand this, if you will understand this in detail once you go into my webinar. I'll teach you all the coordinate system, the transformations. You will see the transformation from cylindrical to spherical without touching Cartesian. Then you will be doing the what shall I say, the vector calculus on these curvilinear coordinates. You will be using indices all through. You will be deriving the vector differentiation formulas using index only, using Levi-Civita symbols and Kronecker deltas, and actually we'll deducing using the component form. Okay. Hope you'll enjoy the webinar. I shall be conducting the webinar very shortly, in a few days. It will be a 15 days class. 15-hour class, 15 day, and that will contain the assignments and everything. Complete webinar on vector analysis. It will be a geometric anatomy of the vector analysis. That will be the topic. Thank you very much.